Good morning, good afternoon, good evening from wherever you're watching from around the world. Welcome to today's Tanzu webinar, Deploying and Operating Dev-Ready Platforms with Tanzu. Now, before we bring in our incredible speakers, just want to go over some housekeeping items. If you guys have any questions for us, please submit them using the Ask Questions tab below, and we'll do our best to answer all of your questions live today, whether that's in the presentation, at the end of the presentation. Stay tuned and we'll get to your questions. In addition, we know that you guys are here to hear from us, but we'd love to hear from you. So if you have any feedback, hit the Rate This tab also below the presentation screen. Let us know how we did, how we're doing, or what you'd like to hear at future events. We do take those to heart, and we do customize our webinar calendar with what you guys put in the feedback. Now, without further ado, let's hand this off to today's speakers. I'll bring them in today. We have Corey Dinkins and Miles Gray. Hey, guys.
Hey, Jay. Thanks for introducing us. Good morning, good afternoon. My name is Corey Dinkins. I'm a technical marketing engineer for Tanzu by Broadcom. It's a little bit of a mouthful to say and something I'm not used to yet, but we'll get there. And I guess, go ahead, Miles.
My name's Miles Gray. I'm also a technical marketing engineer for Tanzu by Broadcom. And I focus on the developer platform end of things.
Yep. And I should probably note that I focus on the infrastructure side. So really making sure that you have things for your dev platform. So let me go over the agenda real quick and just kind of level set for everyone and really take a step back and I guess what I want to say is this won't be highly technical, but this is going to go over how you can use our products within the Tanzu suite to essentially solve some of your day-to-day challenges that you might be facing. So whether that's operational issues with clusters or developer productivity, those are the kind of things that we're going to be discussing today. So first, we're going to be going over the operations side of things. This is really a discussion about how you can lay down the infrastructure and the various things that all your developers and platform engineers are going to need to service the developers and to make sure that applications can actually run and are always running successfully. So that's really what we're going to be talking about in this section. And after that, we'll be going over how you can then lay down a developer platform and make it easy for developers to not have to worry about any of this infrastructure piece. So just kind of going over, why Kubernetes, why all this talk about cloud, there's a lot of people that are discussing this and, we still hear a lot of confusion about maybe why this is happening. And so to take a quick look at the whys, in front of you, you can see a few different stats that are really the primary drivers for container adoption. And the way that I think about this is essentially similar to what vCenter and ESXi has done for virtual machines, where you have improved resource utilization, you have increased flexibility for your server, applications, and you have better utilization, right? All of these things are also true for Kubernetes. So that's why it's becoming this, one of the de facto ways to run workloads. So one of the challenges with running Kubernetes and actually, getting workloads into production and successfully running them is that, one, it's not quite as easy as operating VMs in your traditional server based workloads. And there's a little bit more of a challenge when it comes to doing things like, say, firewalling, maybe firewalling between services within a cluster, things like that. And then probably one of the biggest issues that we're finding is the skills gap. There's just not as many people out there available that know the ins and outs of Kubernetes to be able to do what some of these companies are trying to do, whether that's a net new application deployment or they're trying to bring legacy applications into a more modern form factor, I guess you would say. So, these are all some of the challenges that we're seeing. And Oop, looks like my animation wasn't quite right. But so with these challenges, though, what we're seeing is, customers want to have clusters in multiple different places, and that can be for a few reasons. It can be due to resiliency, high availability. In some cases, for our clients, it's a regulatory requirement. So they literally just have to have things running in these multiple clouds. And a big problem with this is the sprawl issue of, okay, well, I have all these things in these different clouds. I'm not quite sure how I can easily manage them without having, to open a whole bunch of terminal windows and, you know, apply a bunch of YAMLs constantly throughout the day or however many times you need to update. So this is a challenge that we're starting to see increase. It's kind of, again, a similar trajectory that we faced with when you started to, remote desktop deployments and remote offices, where how do I manage fleets of desktop computers, without having to spend days going into each one and managing it individually, right? So we're trying to solve a similar issue with some of the tools that we have in the Tanzu suite and really try to help streamline some of these operations and make it so that you don't just need Kubernetes experts to do anything related to Kubernetes. That's kind of a poor way to scale. So what we're trying to do is give you a global control plane, which, as you can see at the top, we're trying to give it, you know, the ability to group all of these different clusters together in different constructs, and then also potentially network them together with some of our other solutions. And additionally, with the global control plane component, this gives you essentially one place to go and manage all of this. So instead of having 20 control panels or 20 console windows, you can manage these things all through one place. Looks like my animations are a little messed up here. I thought I went through them, but so if you're trying to, build a solution that achieves all the goals that I've just been talking about, where you have one place to go and, you can manage your clusters, you have visibility into what they're all doing, um, you can automate some of your package deployments. You traditionally have to go and look at this CNCF chart and kind of do a pick your own adventure, choosing, packages from basically every section that you see on the screen here. And you would have to then stitch together the solution and manage all of these different pieces. Coming from someone who used to manage, servers in our entire, you know, server environments, networking, etc., adding all of these on top of what I already did would be a pretty big headache for me. So, not something that I would find desirable, but this is kind of the landscape, the Kubernetes landscape as it exists today. If you're doing the DIY, choose your own adventure. So one of the products that I'm specifically talking about today is called VMware, or I guess I should remove that. It's actually Tanzu Mission Control. Still getting used to this marketing. But this is a centralized hub that you can use to start managing different clusters, or I guess not different, but clusters that exist in the same environments or different environments. Um, you don't always need to have, 50 or 100 for this to make sense to you, because even as you start to scale beyond, one or two clusters, there's a lot of tasks that they take up a lot more time exponentially as you start to get to that many clusters. So what we want to do is ease that burden and give you a single control plane that helps you manage all of this stuff. And so whether you have your clusters residing in public clouds, whether you have them in like edge locations, or whether you have them in even private or sovereign cloud type environments, air gapped, etc. This gives you a way to start to consolidate operations and really eliminate control panel sprawl. So what I'm really, I guess, talking about and what we can offer here is things like policy management. So RBAC policies, security policies, etc. We can also do your cluster lifecycle management. So, creating and updating clusters. So we support VCF as a target. So VMware Cloud Foundation. We support vSphere with Tanzu, which is probably what most people are familiar with at this point in time. But that's something else that um, will continue to evolve. And then we also support lifecycle management for EKS and the AKS clusters on those respective cloud platforms. So a pretty wide scope of the different cluster types that we support. And these were the main targets that a lot of our customers were asking us for. So, there's the different cluster lifecycle management on those platforms. You can also do data protection on all of these different platforms. So things like you can back up to local S3 buckets, or you can back up to S3 buckets that may be stored in different clouds if you would like. So things like data sovereignty requirements, this is something that can help with that. And then one of the bigger applications that we hear customers struggling with and why they look at this is for RBAC and identity management. This is something that is a big challenge for a lot of people and something that they lack visibility into because a lot of people don't have the skills in Kubernetes to be able to check these things. So something that we're trying to help with. And I'm not going to spend too long on this slide, but I just wanted to show you, the components that we have selected as, the basis for what Tanzu Mission Control offers. So, looking at that CNCF chart, we've gone through and picked the projects that we feel, will serve you the best. And we automatically deploy all of these things for you whenever you bring a cluster into management. So pretty significant time saver because, again, this is done automatically for each cluster. So, and there's Flux. So again, just kind of reviewing, that was a little, reviewing some of the, operations that we're trying to help you solve and some of the, I guess, efficiencies we're trying to help you with. If you look on the left side of the screen, you see what a traditional process looks like for creating EKS clusters. And, just at reInvent last November, we've spoke to multiple, people that stopped by, and this is what they do today in 2023, 24. So this is still happening. We can really help you convert this process to something like a one-step create, and all of this is done for you, right? So that's what we're really trying to offer here and help you optimize and make it so that, again, you don't need a Kubernetes expert just to create, a cluster that your developers can start using. So again, just another quick review of what this might look like if you were to want to manage EKS clusters with Tanzu Mission Control or Tanzu for Kubernetes operations. So you can have multi-region support. We support, creating accounts for, you can ingest multiple different account types into Tanzu Mission Control. So you can create clusters in different accounts. So if you have dev, test, prod, for example, that's something you can easily do. And so just kind of a quick review of some of the different outcomes that we're trying to bring you. We're trying to give you some operational efficiency at scale, consistent governance and security, and help increase your devs and DevOps to be able to worry essentially about development instead of worrying about infrastructure, which a lot of times is not even in their control. So And I'm going to just spend 1 second on this slide comparing the very top row here, because again, these will be given to everyone, so you can drill into the details later. But there's 2 different ways that you can manage clusters with mission control, Tanzu mission control. The first way is if you have created the cluster or you've brought it in under management and it's EKS or AKS, you can continue and lifecycle manage all of those clusters. The other option that we have is called attach, where you can bring any CNCF conformant cluster type under management with the attachment process, but you just cannot lifecycle manage that cluster. So you can do all of the other functionality, you just can't, create, update, delete, but you can still take advantage of all the other functionality that's offered. So what we covered here was on the right, was VMware Tanzu Mission Control, and it was part of Tanzu for Kubernetes operations. And next, we're going to talk about the Tanzu application platform, which is something that you can actually deploy directly from within the solution. But before we get into that, I want to just go into a brief demo of Tanzu Mission Control and just show everyone essentially what I've been talking about and how you can utilize this in your own environments to start, improving cluster operations.
Corey, while you're diving into the demo there's a few questions. Do you want to take them now or do you want to take them after your demo?
We can take them now.
Okay, there's a good one on whenever we say managing things, does this include primarily infrastructure as code, access code declarative management, or is this perpetuating some kind of ClickOps imperative type patterns that create or cause drift? And do the management tools help backfit changes into configuration management solutions? So just trying to find out what the pattern is, right?
Man, Gary with the hard questions today.
Mhm.
So I think the answer to that would be it's essentially you kind of pick your journey. So it depends on your needs, I would say. Sure, you can use it for a ClickOps methodology. One of the points that we're trying to, I guess impress upon people here is that sure, you should have experts on, the things that are critical to your business, right? You should have Kubernetes experts on hand to do, the things that you really need to make sure, to handle issues that are critical and, applications, deployments, etc. So there's that level of use that you need, but then you also need another layer down of users to support those experts to where you don't need experts bogged down to do any little thing that is related to Kubernetes, right? You shouldn't need an expert to maybe update an RBAC policy or add a user, to a cluster for access, things like that. So I think that's the first layer. If you take a step down below that, you kind of get to the next part where you don't want to run everything through ClickOps because that's not scalable, but you also want to have some kind of baseline that is a standard for all the different clusters you might be deploying and all the different applications you might be needing in these various clusters that you have, right? So once you get to that layer, that's when you really, would be taking use of all the different infrastructure as code and declarative type operations. And that's actually some of the stuff that I wanted to go over now. So hopefully that answers your question, Gary. It's a little bit of both, but the goal is to really give you both of those worlds if you need them, right? And yeah, I'd say I'm gonna go over what's called there's a Flux integration, and that should handle the continuous changes that I think you're asking about. So I'll dive into that deeper.
Cool. All right. We'll keep the rest for later on then, I guess, Corey.
Okay. So let me just go into the demo real quick, and hopefully this answers some of the other questions that we have here. So just to kind of start out, I think going over just briefly So looking at, I guess, a general scenario of how I would generally, have used Tanzu Mission Control in my previous lives, I'd probably be looking at using this to essentially standardize my cluster deployments, no matter where I've had them, and so that the people that are supporting me, again, I can rely on them to go help me do basic operations, but a lot of the bulk of advanced stuff would probably be handled automatically if possible. And so the start of doing that is in mission control, we use cluster groups as the main organizational construct. So with the cluster groups, you can put different clusters within these. So in this one, I don't have too many. Let me see if I have a different one. Yep, so it looks like Bosky's here has quite a few. So you can take any number of clusters and different cluster types. They don't have to be the same. And you can start grouping these together, and then you can start applying different things to this group of clusters. And those things can be anything from RBAC policies. So, for example, say we wanted to assign, cluster operations the ability to manage this particular group of clusters. We can go ahead and do that here. And the way I think about this mentally is kind of like a Active Directory for Kubernetes. So you essentially add, your permissions, and depending on which level you've added them, they will cascade down to the appropriate level. So anything at org level obviously would carry all the way through to all clusters. So when you're assigning permissions and like directly to clusters, this is usually like an operations or platform engineering centric view. Assigning access to like clusters for developers where they can get deploy workloads would be in like the workspace type viewpoint. And the reason for that is when you're looking at workspaces, it's really just a collection of different namespaces. So the goal here is you assign access to a namespace, you give a kubeconfig to your developer, and they access the namespace for, deploying things. That's one way of handling it. But we'll go into how you can automate some of that. And then looking at the other policies that you can assign, these are different security policies. And again, the goal here is to get you out of the, the world of having to sit there and live in 20 different command windows or terminal windows, because you have to remember that you got to apply this new RBAC YAML to each one. And that's your way of, getting through your list. People are still doing that today. So to crowbar you out of that and to make things more efficient, you can create policies one time and they cascade to the rest of your clusters. So makes it a lot easier and much more efficient to be able to manage those. So that's the policy assignment. We have a couple of different policy types that you can assign. I don't want to dive into those right now, but it's a similar methodology where you create it once and it's applied automatically for you as clusters are added or removed to those groups. So going back to one of my groups here, I wanted to look at a cluster that or I guess this group configuration, and just go over how you can start using the Flux integration to automatically deploy a series of applications, or whatever your baseline application might be.
There's nothing to stop here.
Oh,
Sorry.
thanks, Alexa. So if you enable a Flux integration for a group of clusters, you can assign a Git repository, and you can actually scope out this Git repository to a specific branch. So if you're trying to do blue-green deployments, or if you have a dev staging prod type deployments, you can actually scope out different cluster groups to those branches and automatically, as you roll out code changes and application updates, you can validate pretty easily, did the application update, did it fail, etc. So you can also go by tag or semver, commit version, etc. So if you have any kind of automated pipelines where some of this might be automated, you can carry that automation into TMC and essentially do this Git repository creation automatically and refer to your repos dynamically if needed. Like if you really wanted to go that far, you could. Um, so defining our Git repos lets us tell us where the different customizations are. And once we do that, it's going to go ahead and deploy, or once we add the customizations, it's going to deploy some, essentially whatever we've defined in this Git repository. And in our case, I have an example repo here that is going to deploy all the packages that we see here in this list. So external DNS, cert manager, contour, fluentbit, etc. And by adding this repository to this group, any cluster that I add is going to automatically receive all of those customizations essentially. And so if we look at the workloads here, we can see cert managers running. See if external DNS, yeah, contours there. Grafana is running. So it looks like everything is running. And so it looks like external DNS has a problem though. So the rest of them deployed, but what is important about this is if I go into my Git repository and right now I've got Harbor commented out. If we go ahead and change that, we'll just commit and we'll leave this great commit comment because that's really helpful. And once we do that, the cluster is going to automatically reconcile this updated customization file, and it's going to begin the process of trying to deploy Harbor now. So this is a way that you can essentially start defining your cluster configurations as code, and you can start having packages automatically managed and deployed for you. And this can be also done with any native Kubernetes CRDs and things like that. So you can really start to fashion out and build out these different cluster groups based on locale or based on cluster use or things of that nature, and really start eliminating a lot of repetitive tasks that are arguably low value. So and I think that was mainly what I wanted to cover. I know it was a little bit of a whirlwind. So just to kind of recap what we talked about, you can take clusters and create them within cluster groups in Tanzu Mission Control. And what that affords you is the ability to automatically deploy Flux and subsequently automatically deploy any native Kubernetes workloads or CRDs that you need to onto these clusters. In addition, you can also, apply access policies and security policies in bulk. You apply it once and it's applied many times and automatically for you. So a lot of the things that traditionally we needed, the Kubernetes experts to handle because it required YAML and it required command line, you can really start to get out of that kind of repetitive tasks. So, and then kind of a segue into what I wanted to talk about next and what Miles is going to present is, we just talked about getting your clusters laid down and deployed. That's really, one part of the puzzle. The whole other piece to this is how do you actually get developers in there? How do you actually have developers successfully, able to connect to these services and begin iterating, testing, deploying code, things of that sort. And that would be done through the Tanzu application platform. And we've made it really simple to be able to install it directly from Tanzu Mission Control. So it's a matter of choosing your cluster type, deployment type. Single cluster is great for just proof of concept and validation of if this is the right product for you. But multi-cluster is available for fully production deployments. And I'm gonna just pause there and just go back to the slide just to see if there's anything else. But
There's a few great questions that came in, Corey. Perhaps you want to have a look. So there's one in particular around when you create a policy, does this get translated into infrastructure as code, or how is that configuration persisted? And then I think Mark, the same guy, asked, is TMC code configuration in code, or can it be in code?
it can be, yeah. So you can store the security policies and the different RBAC policies in Terraform. You can also manage them through REST API or the Tanzu CLI if you wanted. So you don't have to just go through the UI and click ops your way through everything. So yes, that can be done.
And then could you talk about user management and how users, I think you've covered that adequately in your demo there.
I can, but I can show real quick how that's, how they would retrieve that and what it looks like. That takes just a moment. So Manas, this is how you would, assign your different security access. You can go in here and assign your policies here. Once they've been granted access, your options are you can either give them access to the TMC UI to actually go and pull their cluster config, or you can provide them with a kubeconfig file that essentially, like, I guess I can't open it here, but there's really nothing specific to the user per se. It's really just a standard kubeconfig that points to your endpoint, and our pinniped extension on the cluster is what kind of interfaces and provides the authorization for that user when they try to log in. So pinniped's the one that's doing the auth connection between the cluster and Tanzu Mission Control.
There's a question from Alexandra around, do you plan to support GCP under the Tanzu brand? Well, we support GKE as attach currently. I think that covers GCP there.
Correct, yep.
Sujit asks, does Tanzu support integration with EKS, AKS security control frameworks like Calico?
I don't believe so.
Because we kind of have our own version of that, which is what Corey was showing earlier on with service mesh and so on.
Yeah, and that's the Tanzu service mesh, which is essentially Istio. So, and I guess
it's more complicated and more comprehensive than Calico. Calico is mainly just an overlay network of sorts.
Yep. And I would say there was one more question about you can assign access directly to namespaces, and you can even do custom policies that scope out, user access to specific API objects within like a Kubernetes cluster. So you can set up a service account that only has Git permissions, for example.
Jeremy asks a question about, for mission control and RBAC defined components, what resilience capabilities exist?
It's an interesting question. I'm wondering if this is around, like, if someone tries to change a policy, what happens, like reconciliation and.
I was thinking maybe more control plane. Jeremy, if you want to clarify, we can pick it up at the end of my section.
Yep. Well, let me go ahead and stop sharing and get on to Miles' section here.
Sure.
I've been droning on for a little bit here.
No, it's cool. All right.
So just a quick overview of what Miles is going to be talking about is, the Tanzu application platform can be deployed directly through Tanzu Mission Control. And this is kind of the high level overview of what that solution looks like. So I guess I'll go ahead and hand it on over to you.
Awesome. Thank you, Corey. So Corey's mentioned the Tanzu application platform, and at this point, you're probably wondering, well, what is that? Why do I need it? So let's start with the why, and then we'll get into how it works, and there'll be a little bit of demo later on as well. So the problem that we're aiming to solve here is developer toil. All time that developers spend not writing code or not writing tests, essentially, is wasted time. That's developer toil. It's stuff the developer could not be doing, and instead providing business value by writing logic for applications and so on. And there's a whole bunch of things that could be considered developer toil. There's some stats here from a Gartner survey that was done a couple of years ago that says, what are the top reasons to developers for development friction? What is stopping you from doing development? Is it meetings? Is it, friction between teams? What kind of stuff is it? And if you look, the number one is required handoffs between roles or teams to complete work, right? So there's clearly a friction between development teams, maybe the QA teams, the security team, product management, whatever it is, right? So there's some kind of friction there, which you think might be cultural, and in some cases it is cultural, but you can solve sometimes those cultural problems by forcing them to use a solution together, or building a solution that provides like a clear delineation between the roles of those different groups. Another one, lack of availability, of required expertise. Corey's just spent a whole bunch of time talking about Kubernetes, how it's the future, how it's a fantastic IaaS platform, or how it's a fantastic platform as a platform type thing. And we'll get into that and what that actually means. But Kubernetes experts are not cheap, let's be frank. And most of them are employed by vendors who are trying to build Kubernetes solutions. So you're competing with that level of market. So ideally, you want a platform that takes care of all of the complicated Kubernetes stuff for your developers so that they don't need to spend time learning about Kubernetes. So they shouldn't have to care about it at all. And basically, all they have to care about is their code and getting that committed to a Git repo and moving on to the next thing. So, maybe we can answer some of these problems of developer toil with a platform or with a software solution, rather than just chalking up to cultural or organizational inefficiencies. So Kubernetes is the new IaaS. We used to use bare metal all the time. Then we invented virtualization. Well, yes, we productized virtualization here at VMware. It's been around for a while. But we brought that product to market, and we all know that VMs are the IaaS nowadays, right? They are what everyone uses to abstract physical infrastructure. And to me, my Kubernetes journey started in about 2017. Whenever I first joined VMware, it was one of the primary things I was interested in, and why I joined VMware. But I was working on storage at the time. So I had to be interested in the storage angle of Kubernetes. And the reason I was so passionate about it is, once you get over the learning hump, and believe me, there's a huge one with Kubernetes. It is the closest I've ever come in my life to giving up on a technology because it was just so complex at the time. It has gotten better in time, but it's still not straightforward. And there's a lot of sort of tribal knowledge around it that you just gather through exposure. But it has some really big upsides around reconciliation, around predictability, around scaling, around managing applications as code. Like, it's a really, really fantastic solution. And if you look at some of the stats that we have here, the percentages of organizations that are using Kubernetes in production is only going up. But we're also realizing the challenges alongside that. So lack of internal expertise and experience does not surprise me. Like I said, it is a really, really complex system, unbelievably good whenever you get it working and it does what you want it to do. But the knowledge that you have to have without some kind of wrapper around it is really, really high. You need to have a very, very high skill sort of tiger team to take care of that kind of thing. The next thing, once people get it up and running, it's like, oh man, that was great. It's all up and running now. Life is good. Then comes the security ops team. Life is not good anymore. How do we secure all this stuff? How do we make sure it's compliant? How do we make sure that our PCI DSS or HIPAA applications are indeed secure, or are being built securely, or are deployed securely? There's a lot of things that come in after a new technology is adopted and set up that you should have cared about from the start, but you were so focused on just getting it up and running to begin with that this was kind of an afterthought. And that's okay. There are ways to address this kind of stuff. And difficult to integrate with current infrastructure. Some of that just comes from the fact that it is so modular. You could integrate it with everything that you kind of get spoiled with choice. And you're like, well, should I integrate with this first or that? How do I make it work? Is this a maintained operator? Is it not? There's a lot of things that go into it. Lack of documentation, obviously, open source projects, that's kind of how they are. And lack of clear ownership. And this is an interesting one because some of the questions that Corey got were around how do I assign a single namespace to a user? And you have to ask yourself the question, well, why do I want to assign a single namespace to a user? Should that user really have to have Kubernetes access in order to do their job? Or do they just need to push code and have something else do it? If it's an administrator, fine, maybe they do need Kubernetes access. But if they're a developer, do they really need that level of access? And could a platform take care of it instead? So like I said, the Kubernetes learning curve is steep. I built this slide a couple of years ago. Back in the good old days, you had some code, you copied and pasted it onto an IIS virtual machine, and boom, your web app was up and running. Now, we realized that there's a lot of drawbacks to doing things like that. So we started to containerize things. You build Docker files. Cool, I've got my Docker images. Along comes Kubernetes, and we're thinking, well, God, I've got all these bash scripts and God knows what to try and make my containers run the way I want them to run. I need a solution that looks after that. And that's what Kubernetes does, right? It's an orchestrator. It's there to take care of all of that kind of scheduling, load balancing, all the infrastructure layer stuff to do with containers. There's a lot of YAML that goes into that. Now, I have no aversion to YAML. I think it's okay. The spacing is annoying, sure, but it's not really the YAML that's the problem. It is the breadth of resource definitions that you have to care about to actually run an app in production in Kubernetes. So things that you have to care about: routing. How does the traffic get to the app? Scaling. How does the app scale? Based on what metrics? What measures those metrics? How do you get those metrics out in order to scale on those metrics? Eventing. Are we running the application all the time? Or are we spinning it up on demand based on incoming HTTP requests? How do we do that? Are we using a sidecar? What kind of HTTP proxy? How do we configure that? Deployments. So you can deploy applications in many ways on top of Kubernetes. It could just be a static pod, bad idea. It could be a replica set, in which case you define the number of replicas. It could be a static set, or a stateful set, where there is persistent volumes attached specifically to individual pods. Think clustered database, something like that. Role-based access control also comes underneath that, right? So which model do I choose? Services. So do I need a load balancer? What ingress do I use? How do I integrate with my DNS? Do I use something like external DNS like Corey was showing, or otherwise? And then portability. And this is a really tricky one. And the reason it's tricky is Kubernetes promises to be the abstraction layer for cloud. And that was true at the start. The problem is it is a extremely leaky abstraction layer. The number of differences between clouds, Kubernetes versions, API changes, distributions of Kubernetes. How many times have you gone into a Kubernetes instance and then realized that there's like a million CRDs that you've never seen before? They're creating an ingress or something at some point, but upstream of that, there's all these CRDs that are specific to that distribution. So that means that your cloud agnostic control plane, Kubernetes, is not really cloud agnostic anymore. It's cloud agnostic if you only use that distro. But if you're using GKE or AKS and Azure, and you want those things to be, you want your application to be distributed across those for redundancy, cloud redundancy, whatever it is, you're probably going to have some problems doing that. And all of these things sort of add up. It is very, very complex to get an application running across multiple Kubernetes, across multiple clouds, for redundancy reasons or otherwise. Because frankly, they all require little changes. They're not necessarily huge changes, but they're just different enough to be annoying, and that you would kind of have to dedicate a team to making sure there's interoperability amongst all of them. So Kubernetes is hard. The cloud doesn't necessarily make these things easier. You'll find that as you sort of grow and scale with a cloud, it doesn't necessarily get easier. Number one, you get more locked in, which is not something that we particularly care for in any case. But you'll find that stuff becomes siloed. You know, which account is that in? There's duplicate spending on one versus another because of permissions problems. There's security and governance requirements around, you know, this one is in certain cloud, it's got this VPC attached to it, it's got access to these on-prem databases or whatever. This one doesn't, you know, so the promise is nice, but the reality is different. And over time, you'll realize it gets worse. The reason cloud is nice at the start is because it's a green field, and we all love a green field. Nobody likes to go into a brownfield environment. I used to design infrastructure for a managed service provider. I designed their cloud infrastructure and stuff. And I loved doing that because it was a green field. I had carte blanche. I could go and choose whatever switching I wanted, use what overlay technology I want, figure out how I'm going to build these machines and what ways they're going to scale and all this kind of stuff. I love that. Going into an existing customer environment and onboarding their stuff and porting that from one thing to another, or taking stuff and trying to modernize it, that's really hard. So cloud feels good at the start because it's a green field, but you'll realize that soon that green field turns into a brown field, and you'll have just the same level of complexity because the complexity doesn't go away. You're just pushing the complexity P around that proverbial plate. You know, it doesn't go away, it still exists. So it's still something that you need to take care of over time. All right, so we talked about developers, the problems that they face. We've talked about Kubernetes, why it's really good, but also why it's complex. But I hear you maybe asking, well, why do you care about the developer experience? I'm not a developer. At the end of the day, they write code and I provide infrastructure. Why should I care about that? And the reason is it actually affects the outcomes of your business. There's been some studies done over the last couple of years that showed that the higher developer velocity index, or DVI, companies, excuse me, and there's a number of ways they measured that. It's all on the slides at the end, so you can go and look at the research anyway, showed a 4 to 5 times faster revenue growth in companies that had a higher DVI, as well as they were 55 times more innovative. How you quantify innovation? I'm not quite sure. This is what the study said, but I think we can all agree that 4 to 5 times faster revenue growth or time to value for your customer is very valuable. So what we're talking about here, what I'm going to talk about in this upcoming section and the little demo is the Tanzu application platform. That's part of the Tanzu suite, and it aims to solve a number of these challenges. We want to reduce developer toil. We want to provide supply chains that allow developers to only care about their code, and you as the operations or as the DevOps or as whatever you call that platform engineering, platform ops team, define that pipeline. So how does that code get to production, and what does it look like? It takes care of the Kubernetes operations side of things, not from a Core TMC setting up Kubernetes, but all of those challenges I talked about earlier, routing, scaling, deployment, all that stuff. So it designs the YAML files around the application and deploys them on your behalf. So the Tanzu application platform, it says VMware in here as well, and need to remove that, offers a golden path. And the idea here is if you're a business that has existing application pipelines, and I'm sure many of you do, Jenkins-based or otherwise. So say you've got a whole bunch of Jenkins pipelines, right? One for every different application that you have, or maybe you even used a couple of them for a few different applications. Fantastic. The Tanzu application platform aims to go a step further than that. So instead of having it such that you need a new Jenkins pipeline for every application, or they're very meticulously managed, and thus, you know, you maybe get to reuse certain ones over again, or the modular or whatever, the Tanzu application platform offers a dynamic pipeline. And that means that you can take any application running on a number of different languages. So polyglot applications, maybe you've got some Python in your environment, maybe you've got some .NET Core, maybe you got some Spring Boot with Java, or just straight up Java applications. You got a mixture of things, right? So you got different pipelines for all of these. The Tanzu application platform aims to solve that problem in a single pipeline because it will swap out steps based on what the application code looks like. So if it's a Java app, it's going to run Maven or Gradle. If it's a Python app, it will run PyTest or whatever testing framework you tell it to run. If it's a .NET Core app, it will run XUnit. So based on the source code the pipeline will always execute a certain number of steps. So it's always going to check for CVEs. It's always going to build it into a container. It's always going to do X, Y, Z. But how it does each of those steps can change based on the language, based on the framework, based on the version. So you only have to manage a single pipeline, but the branching logic within that pipeline, and because it's Kubernetes based, it will reconcile itself automatically, which we'll look at in a bit. It's very, very powerful. But it allows you to, instead of having that massive amount of overhead from managing all those Jenkins pipelines individually, you have a single pipeline or maybe two pipelines, depending on your use case, that you manage, and all applications go through those, regardless of language or whatever, that they'll be customized and deployed specifically to the run clusters that you want them deployed to. And that could be across multiple clouds. So not even just your public clouds like your GKEs, your AKS, your EKS, whatever, but on-premises with VCF as well, vSphere with Tanzu. So you can offer hybrid deployments where you have your main stuff on-premises, and it maybe uses some external compute on Google Cloud or whatever. Or if you just want to have it up there for redundancy, or you want the same system to run in two places, one for internal users and one for on-the-road users or something like that. But those customizations are taken care of by the platform. So there's a lot in the Tanzu application platform. It provides value for developers, operators, and security teams. From the developer's perspective, it's really easy to get started with. There's a bunch of learning modules built into it as well. It has a learning platform as part of it. It makes it really easy for them to discover their APIs, integrations with other applications, and that kind of stuff. But I think the best way to show this is really just to show you what the platform is and sort of how all these different things fit in. So I'm going to share my screen here, and we'll take a look at the platform. So this is my Tanzu application platform. This one happens to run in Google Cloud. You can see here the target cluster, GKE shared instance. But like I say, this can run on any compliant Kubernetes. So whether that's TKG via vSphere on-premises, OpenShift, either on-prem or in the cloud, GKE, AKS, EKS, right? You name it, it can run on it. And the powerful part there is it takes care of all the customizations and differences between all those platforms. It doesn't care, right? You just deploy it via TMC or otherwise, and it will get up and running and give you a nice, easy way to give your developers to deploy applications with zero Kubernetes knowledge, really. So we'll take a look at one of these supply chains here. These are instances of the same supply chain, I'll point out. So these are the same supply chain is defined, but these are multiple apps running through it. So if we look at this Acme payment one here, you can see that there's a number of steps in here. It pulls in some source code, runs a tester on it, so runs unit tests against it, builds that into a container image, then scans that with a CVE scanner. In this case, we're using Trivy, but there are many that are supported out of the box. You can build your own integrations as well with this. It'll then build out the configuration for Kubernetes, do any configuration customization that you want. So if you, for example, want some labels or whatever applied to specific workloads from that supply chain, they'll get applied here. Another extremely powerful part of the platform is that if you're offering services to your developers, so say, for example, you have a RabbitMQ operator installed on your clusters, or if you have a Kafka operator or a Tanzu SQL or whatever, right? You name it, some kind of data storage operator or some kind of service that you want them to be able to bind to, the platform will automatically bind the applications to those services. So it can get credentials from those services and automatically slipstream them into the apps at runtime. So the developers never have access to credentials. Instead, the platform does all that plumbing for them. If there are API specifications in the code, it'll scrape them and pull them into the platform automatically. And because I've seen there's been a number of questions around sort of configuration as code, GitOps type stuff, you can see here we've got the config writer, and the config writer basically takes everything that's built by the platform up to this point, so all the configuration, and writes that into a GitOps repo. And that is just the way that Tanzu application platform works. It's 100% GitOps driven. So all of this stuff gets pushed up into a GitOps repo, then pulled down to the destination clusters. That creates a really nice decoupling between the build clusters and the clusters that actually run the application. So your run clusters can be air gapped from the build clusters, or they could be in separate public clouds, or they can have one-way read access, for example. So there's no dependency between those two pieces. Stuff gets pushed into the GitOps repo and into your container registry, and then pulled down onto the destination cluster, and eventually it gets spun up. Clearly, I chose an application that's having a fun time crashing here at the moment. But if we look at it from the developer's perspective, right, what does this give the developer? The developer gets to spend their time in their IDE. We've got a whole bunch of IDE plugins for VS Code and IntelliJ that allow them to access most of this functionality within their IDE, so they don't have to leave their IDE to use the platform. So it's all at their fingertips. There's no context switching. And if you've ever done programming, you'll know that context switching is really detrimental to your productivity. So if we take a look at some of the deployed applications here, we've got Acme Payment, for example. You can see it's got a relationship diagram. There's some really detailed stuff that we could go into, but we've got whole presentations on Tanzu application platform if you're interested. But I'm just going to give you a quick overview here. So I'm a developer, and there's something wrong with the resource consumption in this application. I've been asked to go and debug it. So I will pick the application. Here it is running on the cluster. I can view the pod logs. I can change the log levels live on this. Let me just resize this. There we go. And you can see I can change these log levels live for each component inside the container. So if I need to debug it, I can do that. I don't need to kick it off through the pipeline again. So if we jump back into our pod, I can get more information like the URLs and all that kind of stuff. I can view how much memory is being used. This is in point in time stuff. This isn't really observability, because this is sort of like you're using this to debug stuff. And you can turn some of this off. For example, you'll notice that there's a heap dump up here. If this is a sensitive environment, you might not want that, so you can turn that off. But this is really helpful for developers. So as they send load to this, or as they generate errors or whatever, they can see resource consumption, they can see the routes that are being used, metrics, all that kind of stuff. So that's all in here for developers. Additionally, you really want it to be easy for developers to integrate with other applications in your environment. Generally, that means I'm going to go talk to that team. I'm going to find out where their documentation is, what their API looks like, and then I'm going to go back and forth to figure out how we're going to integrate with this thing. And if we remember, some of the highest resistance to developers actually doing their job was that inter-team friction, and it being unclear as to where information is, how do these teams integrate with each other, whose responsibility is it. So we decided that as part of the platform, all the APIs for every application running on the platform should just be consumed and pulled into the platform itself. So you can see here, we've got our cart API, we've got an overview of where it fits in, what team owns it, all that kind of stuff. And then we can go into the definition. You've got a nice Swagger UI here, and you can actually execute these, and it'll give you, example responses and all that kind of thing, and you can try out against it. So if you're developing an application, this is a really good first place to go. In addition, all the documentation is built into the platform, so it'll scrape any docs that are in those applications and pull them in here as well. So instead of giving your developers access to just raw Kubernetes and saying, hey, why are they not using this? Why is there a problem with skills? Why do they constantly need training on Kubernetes? Maybe the question is, do developers really need Kubernetes? Is that something that they specifically care about? We know that we would like them to use it because it's a great way to manage apps and it makes our lives and ops easier. But if what we want is for them to have a good experience and there to be a low overhead, maybe think about using a platform like Tanzu Application Platform.
Right on time.
Nailed it, as always.
Wonderful. Thank you, Miles, for that. So I think we probably have to wrap it up, but before we do, I just want to answer these two questions because it shouldn't take long. So the first one's from Mark Imperato, just continuing the question on infrastructure as code and what the interaction is between Tanzu Mission Control and if you're using the UI along with Terraform. And the answer is you basically, as long as you don't define an object that's managed by Terraform and modify it in the UI, you won't have a mismatch. So for example, if you want to manage all of your clusters and cluster groups and all that stuff through Terraform, you can easily do that and you can still manage RBAC through the UI if you would like to. So hopefully that helps. And then Jeremy, as far as the redundancy and recovery aspects, so we offer data protection that's powered by Valero, and you can define out data targets that are region specific, and you can also define out, I guess they're region specific, but we also support S3 buckets and Azure Blob. So MinIO would be, the common local solution, but any S3 supported would work. And you can restore cross cluster as well. So something I didn't go over much, but hopefully that helps.
And just I'll add selfishly my own definition to that as well. Whenever you're running applications through a platform, say like TAP, it's one of those things that allows you to add multiple run clusters. So you just have redundancy built in by default. So if you're worried about, how do I recover my clusters and that kind of thing, maybe that's not the question. Maybe you should be thinking about, why am I asking about backing up and restoring a Kubernetes cluster when the idea behind Kubernetes is to make stuff redundant, not recoverable?
Yeah.
Excellent. Thank you, Corey. Thank you, Miles. Thanks to all of you guys for sticking on with us, for asking all of the tremendous questions. We do want to let you guys know that this has been recorded, so you guys can see Corey and Miles on demand anytime. Share it, watch it yourself, share it with a colleague, share it on your social platforms. We do appreciate the time that you guys have spent here today. And most of all, thanks to the two gentlemen here for the presentation. So I just want to say thank you guys. Have a great week. We hope to see you guys at our next event.
Thanks.
Thanks,
Bye all.